All right, so it says the diagram shows a circle with center O. So here's the center of the circle. TA is a tangent. Remember, we say a tangent is a line touching a single point on the circumference. TA is the tangent to the circle. Angle BAC is 58, and angle BAT is equal to 74. And the first one they want us to calculate is BOC. If you look closely, you can see that this one here, the angle that they're asking for would be the angle at the center. Just forget about this angle here and so forth, right? And this piece right here. You can see that it's what we looked at. Angle at the center is twice the angle at the circumference. So whatever this angle is going to be 2 times it. So that will be 2 times 58. And we're done. That's all. 2, 8, 16. 2, 5, 10, and 1, 11. So this is 116 degrees. The angle at the center is 116. All right. So we get that one mark there. Move on. It says calculate the angle OCA. With these guys, you have to be very careful. So you can literally run your hand over it, right? It's from O to C to A. So the one in the middle, this is what they want. They don't want the entire thing. They don't want all of this angle. If they wanted all of this, they would have said BCA. So it's only this little piece. So this could be a little bit of a challenge. All right. So this is the approach that I am going to take. Since I know a couple things, right? I know that this is an isosceles triangle. Let me tell you how I know. Both of them coming from a radii to the circumference. So this one is a radii, and also this one. That means these two angles will be equal. Just a little part here. Forget about that part here. These two angles will be equal. So I know that all triangles add up to 180 degrees. So if I subtract the 116 from this, that will give me the measurement of the two angles combined. All right, so we need 4 more to make 20. So that's a 64, right? So the two angles is actually 64 degrees. And then we can divide, and that will give us 32. So this right here would be 32. This will be 32 as well. Now with the alternate segment, this angle right here, all of this is equal to this right here. And I can find the length of this angle by saying 180. Angles on a straight line add up to 180 degrees, right? So 74 plus 58 plus this would give you the total measurement for all of this. So I'm going to figure out that one here. Let me just use the calculator. When we can bother right. So 180 minus 74 plus 58 equal 48. So all of this is 48. Angles on a straight line, right? So what we are saying, all of the angle here would be 48, all of this. But if this part is 32, to get here, we just subtract 32 from the 48 to get that. Oh, this is supposed to be 32? Yeah. So it's actually 16. 6, 3 from that. So we are saying that this is 16. And that will give you the 3 marks. So they only want this little piece here. They don't want all of this. So we are ignoring the 32 We just need to figure out this part alone. Alright? And see, angles on a straight line add up to 180. So the 74 plus the 58 plus the 48, that will give you the 180 degrees. And also, this angle, if we want, you could find this little piece here. Because look, this angle, all of this equals 74. Because this, all of this is equal to 74, the angle here. So if this is 32, we can actually figure out this piece. Just in case CXC gets mad, I want to ask it. Let us go through it. So that'll be 32 from 74, which will be what? 42. So here would be 42. All right. So me do a whole heap of calculation. Let me check something to see if it actually correct. If I look at ABC, I know we are human. If we look at ABC, we're supposed to get 180 when we add all of that, right? So if the angle there, it'll be 42 plus the 32 plus the 32 plus the 16 plus the 58. Yeah, it gives you back the 180. Because that angle here plus that angle here and plus the 58 supposed to give 180 degrees. Angles in a triangle, right? So 42 plus the 32 plus the 32 plus the 16 plus the 58 give you about the 180 degrees. And also the 116 plus the 32 plus the 32, that give you the 180 as well. All right. That's a very nice one, do you know, guys? It's a very nice one. Make you have to think. So that's the new rule that we didn't look at. The alternate segments are equal. So this angle equal to this one. And of course, this one equal to this one. And remember, angles at a point, angles on a straight line rather, add up to 180 degrees. So make a note of it, guys, and we could look at the next one. This is a nice one, though. All right, so you say the diagram shows a circle with center O. So then told us that O is the center. Work out the size of the angle mark X, which is this angle right here, right? So this one is at the center, this one is at the circumference. Angle at the center is twice the angle at the circumference. So all we have to do, double this, which is 100. So this is 100 degrees. And that's it. All right. Let's proceed to the next one. The diagram shows a different circle with center O. Work out the size of the angle mark Y. The diagram shows a different circle with center. I don't know why I use the word different. With center O, work out the size of the angle mark Y. So they wanted to find this angle here. All the best. No. Probably can beneficial.
All right, sir, my question for this is, my observation, you notice that the first answer that I sent to you, you told me that it was incorrect because I see the O of the origin and I figured out that, all right, you're saying that if the O in the middle would have been the 100 and I was working with the Y as the 50, then I think back on, remember on the first one that you did, you have two diagram in that one. So that's how I think of it back and saying that that would have been the single 90 degree. So my question to you is, when you're going to decide whether it's a double up or a single or a 90 degree, depending on what you see in the circle?
All right. Let me answer your question. You see, all right, if you notice, this is the center, right? But there's really no angle at the center. Like, for example, this, for it to be angle at the center, you have to probably have something like this. Now this is the angle at the center, right? Here.
Oh, so the y would have been
Yeah. So
the
if
half of it. Oh, so once it's not there, once they
so
don't
this
cut
is a
it.
double this, right? Yeah. This the
So
angle
if it
we
don't
do.
cut, work it as a 90-degree then.
Well, not necessarily 90, you know,
No,
because what hap- this is
in
a
this case,
cyclic,
once
you
I've
know.
seen,
This is a cyclic, you see?
yeah. So I'm saying
Yeah,
in this
because
case, once you're seeing one diagram in the center, don't work it as a half and half with for the bottom.
unless you can see the
So,
actual angle form,
yeah,
like
they
what I've
ask, so
done.
yeah, if they put
Yeah.
in stuffs in it to figure it out, yeah, I understand. No?
Yeah.
All right.
So you see this one? We always check if it's a cyclic, as I say. Because with the cyclic, it have a two things. It must be a four-sided and
You're
all
supposed to
the
touch the
vertex.
circumference.
Yeah.
All right.
So this is a cyclic. And then, so that means this plus this is 180. They didn't give us anything about this though. But we know say them two here supplementary. And also this plus this must give you 180. So as I say, guys, once you get the diagram, because what CXC do, you know, they try to put a lot of lines in it. So they don't normally just set it straightforward. They put some little distracting lines and stuff, have line all over the place. But what you can do is to look, if you see angle in a segment, you just look for all the rules one. That's how I normally do it. I look if I see a cyclic, quadrilateral. I look if I can see an angle at the center versus angle at the circumference. I look if I see an alternate segment and so on and so on. I look if I see a tangent between a tangent and a radii. So it's just like you, once you know each rule, you can look and see if you see that. And then you can start put them in. Angles in a triangle add up to 180. So it's like you're looking one for each rule and you cross them off. You don't see that, you try another one and you go. And eventually it comes so easy. This is actually one of my favorite topics, you know. Because you don't have to do a lot of calculation sometimes. It's just for you to see it though. You see, if you don't know the rule, it's so difficult. It is very difficult. But once you know the rule and you can identify, like for example, this, you check if it's four-sided. So you say 1, 2, 3, 4. That's what I do. And then I say, all right, let me check if all the vertex are on the circumference. And yeah, and that's all you need to know if it's a cyclic. And since that, I know that the opposite sides are supplementary. So y plus the 50, it'll give me 180. They didn't give access anything about this, but we know that this plus this is 180 as well, right? You guys will have had those rules written down. So guys, it's just a matter of identifying the rules. So this will be 180, right? And then now you ask yourself, what plus 50 give you 180? And you subtract, right? So it would have been 130. So guys, you just have to identify, as I was saying to my lower school today, go back over the basic at all times. The first part of the class is the most important part. Just like when we have the vectors and we say, all right, it have direction and a magnitude, everything be about for that. So always go back. If you're struggling, guys, just go back to the basic. Is the key. All right. So y that equal to 1/3. Most persons got that though. All right. Let's look at this one. All right. This look like a typical CXC question. No. Someone actually sent me some picture. Guys, honestly, it hard for me to deal with the picture. Probably just have to convert it to PDF. I have about a million picture where people just send me. Is that we can't find the time to convert it to PDF and them something there. But this is a very nice one. It says the diagram shows a cyclic quadrilateral. They actually told us, right? A, B, C, D. The straight lines BA and CD are extended and meet at E, which is this. And they say EA is equal to AC and angle ABC equal 3x. angle ADC is 9x and angle DAC is 2x, and it's not drawn accurately. All right, so that them give you all of that information and them show it. And them say show that x is equal to 15. Not bad. So meds it, guys, and then we come back. All right, so you see the diagram shows a cyclic quadrilateral A, B, C, D. So this part by itself is the cyclic, right? Quadrilaterals. This have four sides, all the vertex hits on the circumference. But they told us that, so we never have to worry about it. All right. Let's say now the straight line BA, so this is a straight line, and CD extend to meet at E. Cool. EA, so that's E from E to A is the same as A to C. So see there, they actually indicate that when you see these little things like that, they put two strokes, it means that both of them are equal in terms of length, so that it automatically make these two angles equal. So that's how I want you to figure it out, guys. When you just see what they give you. Based on what they give you, you start forming your opinion and say, oh, me see that, me see a triangle. Okay, me see that. You understand? Just do them little thing there, and so these two would equal. All right, cool. We don't know if that's necessary in a solution. It's an angle ADC is 9x, so ADC 9x and angle DAC equal 2x. Now they say show that x is actually 15, the value of x, right? Not that the angle is 15 degrees, just the value of x. So we're going to use what they give us to find out x. Reason with me. Hello? You can come back 9, please, because I'm in the middle of a class now. Yeah. Yeah, man, I half a class, but I'm in a class now, so just call me back, please. Yeah. All right. All right. So this is the key to it, I think, right? Because it's a cyclic quadrilateral, we know one thing. We know that this plus this equal 180, right? Because they are supplementary. So I know that 3x plus 9x is going to give me 180. Based on the rule that it's a cyclic, the opposite sides add up to 180. They are supplementary. So based off that, I could form an equation. And of course, 3x plus 9x will give us 12x. They didn't ask us for the angle, they just asked us to prove that x are 15. And then we divide by 12. So that proves the x are 15, right? I could further prove it. If x is 15, I'll go on this one. If x are 15, it means the angle are going to be 3 times 15, right? So this is going to be 45 degrees. I think that's what they are saying. And then this are going to be 9 times 15. 9 ones 90 plus 9, 135, right? So this is going to be 135. So it proves that the value of x is 15. So we'll get that 2 marks there. I think this one is a little bit challenging now. It says calculate the size of EAD. And this will be the angle they want right here. So I could just form it. But this is how easy it is. It looks so complex, but if we look at it closely and consider this triangle, because that's how I look at it, and I say, you know what? Let me make this. I'm going to look at the persons who got it correct if they had the same solution as what I am doing. I need to go back to that. Make that triangle here, guys. we have an isosceles triangle, right? We can figure out this angle very easy, because once we have two sides of any triangle, two angles of any triangle, we can figure out the third one easy. So if we know this, we automatically know this. We're not gonna know this immediately, but we know that this plus this gonna give you 180 minus them two here would give you that angle, the entire thing, and we know this is 2x. So make a reason out that part here. All right, if this are 9x, this should be 135. I'm rub it out to see. But we need to figure out that piece here. Just remember how the triangle did look. Yeah. All right, so if this are 135, and this should be 2 times 15, because we know it's x are 15 now. So that's a 30, right? So that means 2x should be 30. 2 times the 15. God, we never change the size. So this is be 165. Two of them add up to 165. So how much more that one for bet 90? That's about 15. All right, cool. So that means this angle is 15 degrees. Right here, that'll be 15, based on that fact. Because remember, angles of a triangle add up to 180. So if this is 135, this is 30, this should be 15. And if this is 15, it means this one is 15, because they told us that the lengths are equal. See the two strokes upon it? Remember, so you can see the strokes. These two strokes indicate that this and this have the same measurement. So that makes it an isosceles triangle. All right. So these are 15. Rub off a big ugly red circle. And these are 15. So basically now we can figure out the angle here in its entirety. Right? So it'll be 15 and 15, and this is our 30. Yeah. So 15 plus the 15. Because we know say 2x are 30 as well, right? And those three angles plus a little piece there must give you what? 180. So I could call that one here y. Because we always have say x. People tired of the x now, right? So I could use y. So this equal 180. So all we have to do, total these three angles, 15 and 15, 30, so that's 60. That is equal to 180. And then we transpose. So instead of adding, we just subtract 60 from both sides. So that's 120. So that's a very nice one, It's a very nice one. I like it. It only looks difficult, but when you look at it, they give you some nice proofs. So we're saying that this part should be 120 degrees. We could see if it makes sense, right? Because we have sense, right? So if this are 120 and this are 15, that's what? 120 and that's a 135. 135. So that's gonna make this be what? 45. And we know that this is angle on a straight line, right? So if this are 135 plus 45, that gonna give you 180. So that just show you say it's correct, right? Angles on a straight line. Remember to put the reasons, guys. CXC care about the reason a lot. Don't put the reason. So that one here is a proof, basically. CXC don't normally give proof, but yeah, they will probably say that something like that. All right. So this add up to that, and yeah, I hate that. But I like this one. This one, it's set up more like CXC. They will do something like that, along with some more lines. And we're flinging some more lines to try confuse you. But guys, if you know the rules, them can't do nothing to you. Nothing. All right. So just know the rules, and then we can take it from there. Alright, let me just put this on the screen and then we can move on. We have 40 minutes left. Let's see if we can make some use of it, guys. Alright, so it's a write down the value of x, and for b, it's a calculate the value of y. So clearly we can see that if you look at this portion here, let me try to see if I can highlight it. Isn't this what we get in our book as a rule? Just focus on this part and I'm going to try to draw. How I'll go on for that. Oh, there. Yeah, yeah. Computer moves. Yeah. Isn't this look at the angles in the same segment, guys? Right? So x is equal to 40. Right off the bat. 40 degrees. You notice how them say write down? Literally enough doing calculation, right? Alright, I can figure out y now. I'm going to meds y deeply. Use a different color. If you look at this, couldn't we two way we can do it, you know? This one is an quadrilateral, cyclic quadrilateral. The one here I'm going to put in a blue. That's the easiest way to figure it, I think. Isn't this a cyclic? Because look, it's four-sided. All the something is on all the vertex and the circumference. So wouldn't it be just be y plus 40 equal 180? I'll show you another way where you can get it. For some persons like to go the long route. Let's see if we can accommodate those persons as well. So that'll be 180 minus the 40. So clearly y is equal to 140 degrees. But let us look on it. So we never see that. As long as everybody will see it off the bat, right? Some people will see it different. But let's look at this one. Isn't this another cyclic quadrilateral? If you look at this one, 1 vertex that 2, 3, 4. So that means that this plus x equal 180. But what is x? 40 again. So there's two ways you could have looked at it. You could look at it this cyclic quadrilateral that I drew last, and you could look at it this way. So anyway, look at it, y 140. All right. Guys, you just have to look at them, look for each rule, which rule you can figure out. Because no matter how CXC try to make it complicated, it's always going to be simple if you know the rules and if you can identify each one of them. So then you can draw all sort of foolishness. It don't matter. Once you know what is angled in the same segment, the alternate segments theorem, you know angles of a triangle equal 180. You know isosceles triangle, base angles equal. You know a cyclic quadrilateral, tangent, angle between tangent and radii and them something there. Once you know the rule, you can find many ways to get the answer. I think I worked this one on my channel today. This one. The board of school. All right, let's go. So it's a and C are points on the circumference of a circle, center B. AD and CD are tangent. Angle ADB is 40 degrees. Explain why angle ABC is 100 degrees. Try to see if we can, we have 20 minutes, guys. Let's see if we can complete. Everyone can complete and more can go through. All right, so you say A and C are points on the circumference of the circle with center B. A, B, and CD are tangent, which are these two, right? angle ADB equal 40 degrees. Two ways you could approach it, guys. It's a explain why angle ABC is 100. We could say that angle between the radii and the tangent are 90, right? So this would be 90 degrees. So if this is 90, this would make this 50 because angles of a triangle are up to 180. So if this is 90 by itself, this plus this given 90. So that means this is also 90 because angle between the radii and tangent are 90. So that means, well, this is actually 40 as well, because that them bisect the line, right? So this is one way you could look at it, and then this would be 50. So boom, them get them answer, white at 100. Another way you could look at it, since you know that this side is equal to this, right? This would be 80. And we know that the entire angle supplementary, this supplementary to this. So this, the 80 plus the angle here would equal to 180. So if this is 80, that will make the entire angle be 100. And that's it. All right, so. Oh, I moved too fast, guys. Sorry. So made it, guys. I moved too fast. Probably ask you guys to see how it go. I could finish the last one, so we don't have to come back on this particular paper. You guys get some sir? All right, so it's now ABCD is a cyclic quadrilateral. So ABCD, right? PAQ, that's the tangent. BC or BC, the BC equal to CD, and AD is parallel to BC. This is very important in solving. And angle BAQ equal 32 degrees. It's a find the size of part. You must show all your working. All right, so first they give us this 32. Remember, just block out them something out of your mind, right? Think of that triangle here and this angle here. This one is equal to what? 32, right? Alternate segment theorem. So this is 32. Once we get the 32, I don't it done. Because they are parallel, they form what you call an alternate angles or Z angles. So this is also equal to 32. So probably is a different line. What go on here, man? And if you look at this, this is an isosceles, right? This angle equal to this angle. So this is 32 as well. So if, this them want, right? So 32 plus 32, 64. So I can figure out this one, as I know that this plus this give me 180. So it will be 180 minus 32 plus 32. So it will be 32. So that equals to 64. So if we subtract, no, I think it is equal to 64, because even if I even subtract, 64. Because tell you what, if you even subtract the difference, you're going to subtract it from 180, because that and that, yeah. 64 answer. We do it today, we did it on my channel. I think I TikTok and put it down. Alright, so 180 minus 64. But we are going to still do the difference, right? So this is 116. This should be 116. But this minus this, this plus this, we get 180, which is 64. So let's say we never have no 64, because these two come to 64. It should be 180 minus the 116, and you'll still get it. So 64 answer. I think Chevy got that, Remember my answer to me, Chevy, and yeah. But I remember you got that. Good job. So guys, we are going to end, But next week, Sunday, we continue some more questions, all right?
When should I come back on Wednesday?
Well, we're gonna do the same exact thing on Wednesday.
All right.
So yeah, like how you guys do it, they are gonna do it. The next class is gonna do it. So Sunday now, everybody are gonna do a new paper. But they're gonna do the same thing that we this exact paper. Alright? So only Sunday class we have in common. See nobody if who
Sir,
want
can you
call me.
please send me the rules when you have the time?
Or I actually send it out, just text me and make me forward it. That's the rule and make me just cause I forward it to Alia finally and another person. So I'm just text me.
Okay.
Yeah, I think Abby got it as well. So take care, guys. See you guys Sunday, alright?
Okay.
Take care. So text me here, please. So as 9 o'clock it will start ringing. Hello. Hi, good night.